As always, if I underline something, circle something, we do the same thing. This rule is really almost everything, or 95% of what's going to be on the test. It'll just be variations on this rule. Let's put a couple of distances on this triangle. As you saw, some distances make a triangle and some distances do not. If they make a triangle, then any two sides added up will be greater than the remaining side. So we'll start with AB plus BC is supposed to be greater than the remaining side. What's the remaining side? AC. Let's put some numbers in there. We've got 10 plus 14. Is 10 plus 14 going to be bigger than 12?
Yes.
Yes. But we got to try out all the possibilities. We've got BC plus AC should be greater than AB. That's going to be 14 plus 12 greater than 10. Is that true?
Yes.
That is also true. And our last possible combination would be AB plus AC greater than BC. That's 10 plus 12. 10 plus 12 greater than 14. If all of those are true, which they are, that means that if I handed somebody the lengths 10, 12, and 14, whatever units they are, that would turn into a triangle, and it wouldn't be this kind of situation where things don't reach. And notice, what's the symbol? Greater than. Equals doesn't work, less than doesn't work. We don't want to do all of that every time we have a group of three numbers. It turns out that those, or that instance is enough. You notice a pattern here. Two smallest. What you can do is pick out the two smallest sides, add them up, and see if they're bigger than the remaining side. That's enough. If that's true, then these two will also be true. So let's look at the 4 at the bottom here. If I've got 5, 5, and 8, what are the two smallest ones?
5, 5.
Add them up. What's 5 plus 5? 10. 10, is that bigger than 8?
Yes.
Your answer to that is the answer to whether or not it's a triangle. So when it says whether the given lengths could be the lengths of the sides of the triangle, you've answered the question. What kind of triangle would 5, 5, and 8 be? Most people get things wrong on this test because they're not reading directions. They'll either answer half the question or a part of the question and forget about another half. Read the directions, you'll be fine for this unit. This one, doesn't matter which two I pick because they're all the same, is 34 greater than 17?
Yes.
What kind of triangle? Equilateral. What should I be adding in number 3? 6 and 8. These examples have everything listed with the two smallest first. It won't always be that way. You might have to search for the two smaller ones. Is 14 bigger than 10?
Yes.
This is also a triangle. It works. What kind of triangle has no sides? Scalene. How about number 4? We got 18 and 13. That's 31. Is 31 bigger than 37?
Yeah.
Put a less than symbol, circle it, so we can tell that that's different. And that's it. If it's not a triangle, we wouldn't name it. It's not a triangle. And that's a situation like we had before. It doesn't quite reach. And this example that I'm holding in my hands is a situation where it's equal. It would collapse perfectly onto the other side. So even equals doesn't work. Turn your paper over. Sometimes we have a situation where we don't know all three sides, and we only know two. If we know two, then the triangle could be really thin, or it could be really obtuse. But at a certain point, it gets too big, and at a certain point, it gets too narrow. Up here, next to number 6, let's draw a little picture. This is what we're looking at. We have 13, we have 16 centimeters, and we have an unknown side. Since we don't know the angle, it could be anything. This little side right here would be the third side. Now it's getting bigger. Now the side's getting bigger, bigger, bigger. No good. What's this distance?
20.
Not degrees, but distance. How'd you get 29? 16 plus 13 is 29. That's no good. If I go this way, good, 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 no good. What's this distance? Oh, you get 3.
16 minus 30.
Notice that the missing side is being referred to as x. Given the length, find the range. That's the range. The third side could be something as small as 3.1, could be as big as 28.9. As long as it isn't 29, which works out to a straight line, and as long as it's not 3, which works out to a straight line, we're okay. Everything in between. So there's infinite answers. We can't write out infinite answers, so we give the answer as an inequality.
That's great.
Are you happy and delighted?
Yes, sir.
What am I going to put for number 5? What are the boundaries of the third side?
8 and 4. 8 and 4.
6 minus 2, 6 plus 2. Right now, all of our examples have the same units. Later on, they might not. You have to pay attention. How many inches in a foot?
12.
How many feet in a yard? How many feet in a mile?
5,000. 500. 3,580.
5,280.
You guys, he said 2,000.
So what was the first
I told you.
And you're expected to know your metric system pretty well. This is 5 and 49. This is 4 and 60. If the units are the same, you don't have to put the units in. But if you have different units and you do some conversions, put your units in your answer always. What's 1.9 minus 1.9? 0. It's okay to have your boundary as 0. It just means that x has to be above 0. We have 3.4, 8.4. Everything else you're going to see is going to be some sort of variation on that. If you read through number 11, Mary has these pieces of rope. She's going to use 2 of the pieces. So what should I do with those 2 pieces, 4 and 8?
Circle.
What did I do with them up here?
Oh, put them in the
So we're going to use x for our third side. But that's not my answer. In this problem, there aren't infinite answers. We've only got these 5 pieces of rope to deal with. We've got 12, 7, 4, 8, and 2. Which ones have we already used?
4 and 12.
4 and 8. So out of 12, 7, and 2, which one of those falls within our boundaries? 7. 2 is way out of our boundary. What about 12? 12 is no good. That would be our case where it's a flat line. It's got to be less than 12. So 7 answers this question. Classify. We started with 4 and 8, and now we have the third side is 7. What kind of triangle is that? Scaling. That's the triangle inequality theorem and everything based on it.